Alright, welcome back to Meteorology 101. In this video, I'm just going to talk about the charts. We're going to do the upper levels. I'm going to save everything and see what's going on with the synoptic situation. Maybe get a look at satellite. And we got a tropical storm out there, Blanca. That's pretty much a big blank. It's just going to stay out to sea, move to the north, and dissipate. So nothing to worry about there. Start with the surface chart. Sea level pressure. So we can see the semi-permanent high pressure system over the Atlantic is ridging into the eastern United States, and pretty strong ridging all the way through the central U.S., all the way over to Colorado. Low pressure in the southwest, and then just some remnant low pressure systems to the north. Wouldn't really call all these lows. We'll look at the data, try to decipher any of that. Once you get into the mountain range, you get all that data kind of get scattered, and the computer just starts throwing highs and lows everywhere. So like this low pressure system off the coast of Oregon may or may not be there. We can look at the high pressure system, that semi-permanent high over the Pacific, and then onshore flow over California. We'll get a good look at the satellite, see what's going on, if we can place our jet stream, and see what kind of weather we have associated with these systems. So we do guys are troughing in the southwest, the Four Corners area, ridging over Colorado, like we mentioned, pushing into the Four Corners, and then troughing over Utah. So let's throw our isotherms on here, see what's baroclinic, what's barotropic. Baroclinic's just where the isotherms cross the isobars. Isotherms are lines of equal pressure or equal temperature, and isobars are lines of equal pressure. So when they cross, that is a baroclinic system. That means there is thermal advection. So the high pressure system over the Atlantic is creating thermal advection, pushing onshore flow. Pretty weak with these isobars spread out like this, but the isotherms are crossing, so there's some very weak thermal advection there. Let's go with the surface plots and see what kind of advection we do have. So 5 knot winds, 10 knot winds, really nothing significant. We do have some cloud cover, looks like broken clouds all the way through. We have ceilings all the way through most of the United States, and then we get into the marginal VFR conditions where ceilings are between 1 and 3,000 feet, and light isolated area right there in Arkansas where ceilings are below 1,000 feet. It looks like maybe a ceiling of 600 feet right in that area. It's a ceiling 1,600 feet. So we are at, that is 1,600 feet. That's the marginal. That's the blue station. And then 4,200 feet to the west of that. Looks like 600 feet right there in that IFR condition. So we got pretty strong ridging throughout the whole United States. Let's go look at a satellite real quick and then get an idea what's going on there. So we played a satellite loop. Now we can see all the way off the northwest coast. The clouds are pushing to the north, wrapping around, pushing back to the south. So it looks like a pretty strong ridge right there over the northwest. And then where that low pressure was around the Four Corners to the south of that, got some wraparound, just southwesterly flow pushing into Texas, New Mexico. A lot of upward vertical motion in the all along the mountain range right there, and then pushing all the way down into Mexico also. So and then the ridging over the eastern United States. I see some cirrus spilling over the ridge. So we had that ridging. We had that ridging all the way into Colorado. So high pressure pretty much dominating the whole southeast, pushing into the central U.S., and then looks like that low pressure system may be pushing up against that high and then pushing all these clouds up over that high pressure system to create that lift and creating all this convection all through the southwest. This higher cirrus clouds, cirrus stratus, then overspilling over that ridge. We can see the cirrus right along the ridge line there, and then, like I said, cirrus stratus. We got some low clouds in the central U.S. That's just kind of hanging out there. There's really not a lot of movement there, so we do have that high pressure. So we just got basically the upper level flow pushing in over that high, and then just creating some clouds cover right there with the moisture. Maybe a low pressure system well to the northeast. See a little bit of rotation maybe up in that corner, and then the tropics are pretty lit up as far as the convection, and we're just pushing right over that land. So we got the mountains of Cuba causing the upward vertical motion, plenty of moisture from the ocean, and causing pretty much all that convection in the just like I said, over the tropics and the Caribbean. Alright, so marginal VFR going to IFR, and then VFR conditions with ceilings all through pretty much all the southeast United States, and then pushing all the way up to the central U.S. also. Not a lot of major wind flow here. Looks like the winds are pretty fair. We had about 6-7 knot winds today in Ohio, right there in Ohio. So we're pretty calm right now. Being in this high pressure system, the ISO bars are pretty far spread apart, so we're not getting any pressure gradient force on that. So I want to mark this as a surface chart, and I want to save that. I want to build a surface chart without highs and lows, and then I'm going to insert the highs, lows, and the fronts. Get an idea where the fronts are. Shouldn't see a lot of fronts on this chart though. Maybe something out of that low pressure system that's here, but that's more of a troughing area. But we do have an upper level area. Like I said, that if you look at that satellite, we've seen that wraparound right down there over the southwest United States. That's probably looks like almost a cutoff low starting to develop there. And then the high pressure that's ridging all the way into Colorado. It's a pretty strong high pressure system, but it's really modified air mass. Warm, moist air being pushed in from the south and causing all the cloudiness pushing up over that ridge. And then any upper level flow from the west, bringing any moisture in, overflowing on that ridge. We've seen that cirrus dropping on the over the ridge on the satellite. Now there's a surface plots we throw on the fronts. Right, so we got a little bit of warm air advection in the south, right there over Oklahoma or Arkansas, and then a little bit of a low pressure system right there, some troughing. So that's pretty much causing any disturbance right there. A little bit of troughing over New Mexico, pushing into eastern Texas. So look for any convection right there. We had all that troughing pushing into that ridge. So there's our instability. We got the moisture. You got the lift. You have everything to create thunderstorms all through that area. We've seen all that convection right along that mountain range. And then most of this stuff was just pretty stable clouds pushing with this warm, moist air from the south. I would expect with this being a frontal boundary, if they're considering a frontal boundary, which it looks like it is, with that warm air advection from the south, it is pretty stable. But we can get, when you get pushing up over that boundary and pushing into that ridge, then the instability with the troughing, then we get that convection right there over Arkansas. So there's your lower ceilings, and would look for any possible heavy rain thunderstorms in that area, because you got the southerly flow, you have the moisture, you have the reduced visibility, the reduced ceilings. So any major storms are going to be right there over Arkansas. So this stationary front pushing through that high, that's really probably not there. Probably trying to separate a couple of these highs, this computer system, so it's just putting a boundary there just to kind of separate a little bit of that. Cold front well to the north, so our Arctic air is well to the north and not looking to be south just yet. If that ever pushed south, that'd be pushed south and stay. Wouldn't make it very far because of the high pressure system. That semi-permanent high will just block that off. That's like the tropical storm out there. Once that starts coming around, if that was a little bit further to the south, I would look for that to steer up around this high, but that's not going to happen. So I would say it's just going to push up to the north and then just dissipate right through that high pressure system. Just going to pretty much absorb it, just fill that in. Alright, so we're going to label this one the surface also, which is with our surface fronts. And I'm naming these charts so you can't see my window pop up, but that's basically what the typing is. So I do save these charts. I put them on my website, meteorology101.com, and you can go on the right hand toolbar. You can see the surface and upper air charts, and you can get to these pretty much updated daily, so you can go check those out. Next chart I'm going to do is a thickness chart. This will give you an idea where the jet stream is. 1,000 to 500 millibar thickness. So we can see where our higher heights are, lower heights, high pressure, low pressure, and like I said with the jet stream. See where our thermal gradient is. That's pretty much the main thing we're looking for, is jet streams on this. Alright, so it looks like the high pressure system is just a cold core system right in the center of the United States. Not too sure how accurate this is, being it's almost like there's a polar outbreak pushed to the south, and then it's just sitting there spinning. But that's what the lower heights in the center of this thing. We go to the higher heights as we go out. Pretty much that'd be like a pretty cold air mass pushing through there. I'm not buying that data very good on that one. So we'll pull another thickness, a little bit of thickness, and we'll see what kind of data we have in this area. We'll go ahead and export that just for the fun of it. So let's pull the thickness. It's more of a balanced thickness. So now we got the warm core to the south, but we're pretty equal here. This one would make a little bit more sense. Throw the surface pressure on here, and then the probably should have went with 500. Well, there's a 500 millibar heights right there. So we're a lot more accurate right there. So I'll mark this the thickness. Alright, so I'm going to pump up the population on the plots, and then we're going to go into the upper levels. Let's go up to 5,000 feet, 850 millibar. We're going to build a chart with moisture. constant heights, isotherms. So we got 850 with I'm gonna go more balanced height. We get this thing showing a higher pressure over Mexico, just sitting there. Got a lot of moisture at the 5,000 feet level, eastern, southeast United States. So that's pretty accurate with the cloud cover that we've seen. But I'm gonna go ahead and erase that for now. We're gonna go. Let's run our moisture first. Now we're going to run a balanced height on this pressure. It takes a little bit longer to process that data, but it'll give us a more accurate reading for where the highs and lows are in the upper levels. Sometimes you get a upper level system and this program doesn't handle it very well. But in this case, it looks like this one's still got that high pressure over Mexico, so it looks like it is handling that one pretty well. So let's go back to the 850. Let's build the chart from scratch. We'll do the whole thing. We'll leave it as is. Looks like high pressure over Mexico. 26 degree isotherm around the four corners where that low pressure system was. That's a warm core low. All the moisture to the south, all that warm moist air being pushed from the south around that high pressure, the semi-permanent high. So we're going to label this 850 and then save that one. Alright, so we'll go up to the 700. Really not a whole lot going on here. We have the high pressure dominating over the southeast. Got that high pressure, just look like an isolated system to the south. If that's accurate, I would say no. I would kind of balance that out a little bit and bring this ridge over and kind of absorb that into that system. It's just having trouble. The computer's having trouble with the data, so it's kind of separating these highs. So you'd have to have a stationary front through this area if that was the case. I'm not buying that one. You do have some rotation right there, and then some ridging, and then troughing over Arkansas. So that's an upper level low pressure system almost right there. It actually is a low. I would almost close that low right off right there for being an upper level low. So if that's the case, then we look for that upper level low to follow that jet stream. We've seen that jet moving up on the satellite and all that cirrus overspilling that ridge, so the jet stream is pushing to the northeast. So if we bring that low pressure system to follow that flow, then we're going to be pushing up into Illinois, Indiana, and Ohio with that upper level low. So that's going to cause some minor short waves to go around that low pressure system and then create rain showers all through Tennessee, Kentucky, Missouri, pretty much all through that Midwest area. Alright, so let's go to the 700. We'll go up to about 11,000 feet. Still have the moisture over Arkansas. We're pushing into the upper levels there. We've got ridging over the east coast, troughing over the central U.S. It's still showing that high down over Mexico. Like I said, I would kind of absorb that into that high and equalize that out a little bit. Not be that that strong of a high pressure system over Texas. So onshore flow, we do have a southerly flow, moisture. Like I said, troughing. There's the long wave trough, long wave ridge. As we get into the upper levels, we start looking for the jet stream. So we're in the about 11,000 feet right now, about 10,000 feet or so at 700 millibars. So you got your northerly flow shifting westerly, and then from the southwest, and there is a little bit of indication of a easterly flow. So you could almost close a low pressure right off over northern Missouri and Iowa. So that would give us our instability and isolated rain showers through those lower ceilings, or those broken to overcast areas where you see all the black in their stations. So you do have significant moisture all up in those areas. All right, so we're going to label that 700. Save it. And then go to the next level, 500 millibar. Now we're up to about 18,000 feet. Pull vorticity. We'll see our upper level divergence, any indication of rotation or upper level divergence based on vorticity. Still showing that high pressure over Mexico, Texas. Like I said, is that there? Is it not? Here's breaking off high pressure over the southeast. Still got significant moisture over Arkansas, even further south into Mississippi, and pushing all through the Midwest. And then we got let's see if there's I don't see the low pressure indicator of low pressure over that. We got the ridging over the East Coast, troughing, pretty deep trough in the central U.S. So that's going to be pushing to the east and giving that low pressure system, the upper level low we've seen, giving that support that's pushing through the Midwest, and then causing that could give us a pretty good chance of rain showers throughout the Midwest for the next few days. That's at 500. It's pretty significant trough. It looks like it's pretty barotropic, not a lot of thermal advection going on. So, but it still is instability, and it is upper level support for that pressure system. Alright, now we'll run a vorticity chart. Alright, negative vorticity throughout the United States mostly. Nothing real significant, so possibly some severe storms in Arkansas and stuff like that, but I wouldn't expect to see a whole lot going on. Maybe some isolated stuff. No major systems pushing through right now. So let's go ahead and pull the vorticity and throw it on this chart also, so we can see any advection. I mean, if you got positive vorticity over Nebraska, really not any advection though. So this chart's pretty accurate on the advection side. It's not picking up any major positive vorticity advection to indicate any major upper level divergence to give strong upper level support to any strong tornadoes, thunderstorms. I mean, you can still have tornadoes and thunderstorms. This is just not giving that upper level support. Like for this long wave trough, that's a pretty deep trough in a 500, but we're not getting a strong positive vorticity advection. Maybe put a little bit of weakness right here pushing into Arkansas. So if I was to see any severe weather, I would say in eastern Oklahoma and pushing into Arkansas. Just based on that right there, that would be about it. We have all that convection over here around the four corners. We push in eastern New Mexico into the panhandle of Texas. We had a lot of convection going there, but that was more of that low surface low kind of pushing into that high and then pushing, giving that lift. And we had the instability and moisture there, so that would cause any of that convection right along the panhandle area. We're going to label that 500 millibar vorticity. Alright, we go to the 300. Alright, now we're getting into the upper levels where we can see where our jet is. We still have significant moisture in the Midwest. Even down into Arkansas, there's at least 60% relative humidity. Broken, overcast, 50 knot winds, the upper level jet into Ohio, and that's right through that ridge. Now we got northerly flow in in the west over the mountains. So winds pushing out of the north, shifting to the west from the east over Arizona, and then wrapping back around. So there's our long wave trough, wrapping back around over New Mexico, and then the ridge obviously we had through the Midwest with that significant moisture and the higher level clouds, all that cirrus stratus we've seen on the satellite. So we got a long wave trough right through there. It's almost starting to become a cutoff low. It's labeled at 300. We'll look at the jet here in a minute too. At the 300, we'll see how significant that jet stream is. Alright, here's our jet maxes. Pretty weak. We got the ridging. You can see let's get some pressures on here. Winds out of the north. We said shooting all the way back to the west, wrapping back around. A little bit of a jet max over Texas. Maybe pushing out of that trough into Arkansas. That would give that upper level support for that moisture. And then we had that real weak upper level divergence based on vorticity. So I would look for any significant weather to be in Arkansas at this point. So low pressure wall to the north. Probably some advection up in that area. We've seen that cold front on the surface. Very weak advection. So this would be almost warm air advection on the eastern side of that low. Cold air to the west side of that low. Almost stationary. That thing's just sitting there kind of spinning, and then that thing is just going to keep pushing to the northeast following that jet flow pattern, and then probably just curve on up toward the Arctic and die out. Here's our plots, station plots. So significant moisture, like I said, still in the Midwest, and we're still over Arkansas. We're still looking pretty good right there too. So we'll go ahead and label this one 300 also. And then we'll save that as 300 millibare jet. Up to the 250 millibars. It's about right about 34,000 feet. Alright, now we're starting to look a little bit better on the jet stream. We do have that northerly flow, and then that's going to go a little bit northwesterly or northeasterly, pushing down to the southwest, and then back around with the jet finger coming up from the southwest, and then pushing up over that ridge. So there's our jet stream right there. We can see the flow wrapping around, coming up into that jet max right there in the northeast. Throw the heights on here with the temperature, station plots. See what we're working with. Okay, so here's the long wave trough. Like I said, that's almost looking like that's becoming a cutoff low. This looks like maybe that jet max is part of like maybe the subtropical jet. All right, so we got the 250 millibar jet saved. And then we'll go up to the 200, and now we're pushing up to just under 40,000 feet. It's right around 38,000. Alright, let's get do the winds. Here's our shading. Now we can definitely see that northerly flow, not wrapping around for that jet finger all the way. Like I said, it's almost becoming a cutoff low. Pull up the models and see what happens there. Either one or two things are going to happen. You're going to get a cutoff low. You're going to leave a jet finger back over the four corners, and that's going to be a low pressure system that sits there and dies out. Or you can get a low pressure system cut off and sits over the four corners, and then a major shortwave comes along and pushes that low pressure system, kicks it, and then that follows the jet stream on up to the northeast. It creates a low pressure system that can push to the northeast and then cause significant weather throughout the Midwest. Not likely to happen in this scenario right here. That jet stream would be more to the west if I would expect that. I didn't see any. We did have a little bit of a low pressure system over off the coast of Oregon if that was there, but that's a little bit further north, so I would look for that. This time of year, when you get these high pressure systems pushing to the north like that, they pretty much block any major short waves from coming through to create a kicker to push that low pressure system out from over the four corners. So not likely going to happen. We're dominated with high pressure over the Pacific and high pressure over the Atlantic. So any hurricanes, tropical storms coming in, they're going to have to stay south and the most likely come up into the Gulf during this time early in this season. Alright, let's get some pressure on here. Now, the only other thing could happen, this trough cuts off, leaves a little bit of a remnants of a trough over the four corners, and then that trough just starts to fill in pretty rapid, which that's pretty good chance of that happening with these high pressure systems, the placement where they are. Because a high pressure system, when you get that high over the west coast like that far north, then all that cold air out of the north is just going to push into that trough and then just fill it in. Pretty significant low pressure system all the way up to 40,000 feet with this that one to the north, but that's pretty vertically stacked. That was a pretty barotropic system. Let me get the isotherms on here. Little weak advection to the west of that, and we got some pretty good advection to the east of that. So I mean, that is a pretty significant system. But like I said, there's only one steer pattern here. That's around that ridge, and that's up to the northeast. And warm air advection well to the north. There's cold air advection. That cold front is well to the north, and it's not going to really push too far south. I don't see that happening. I mean, it could with this trough is pretty deep. We do have some pretty good thermal advection. We're over the Great Lakes region, just west of that over Iowa. So if we had that cold front, I don't really see the cold front. I'd say that cold front's going to go just stay well to the north. And we'll pull another chart to see what with all that negative vorticity advection, this frontal system, I would say it's more or less going to be dying out than it is to be intensifying. So we'll get a look at that Frontogenesis chart and see what kind of see if that frontal system has any chance of surviving. All right, label that 200. Get rid. Then we'll save this one. 200 millibar jet. That's a pretty significant turn right there. What happens when the cutoff low is with the jet max to the north. You get the northerly flow pushing all the way to the south and then curving to the west, and then has to wrap around and come back from the southwest. It can't make that turn, so that energy has to. It just basically overshoots that trough and then just creates a low pressure system kind of separate by itself, and then just creates a long wave trough, and then this trough starts to fill. That low pressure system just sits there and kind of just spins out over the four corner area and then fills from the bottom up. So we can get a cutoff low there. Like I said, I'm not really seeing it here. That's a pretty sharp turn. That thing should have broke off already. These winds are actually pushing from the northeast pretty strong. And then you got that type of troughing. I just don't see that happening. I see this more or less just filling in than it is becoming cut off. Let's run a Frontogenesis chart. Let's see if those fronts have any chance of survival at all. That's just going to be basically based off that vorticity. Do we have upper level divergence to allow that system to intensify? So if the front extends to the west over Wisconsin, Minnesota, then you have a little bit of an area. That low pressure is way to the north. The upper level low is almost vertical with that front. This low pressure system is pretty much not there. We just have warm air advection all along the Gulf states from the high pressure just pumping the warm moist air from the south. And then some isolated shortwave troughing pretty much over Colorado, New Mexico, and then Arkansas. So like I said, Arkansas is the area of concern. If there's any kind of we got this warm moist air being pushed in from the south, and then any kind of lift that's right along Arkansas right there. Troughing all over the four corners, even right around that high. We got a little bit of minor short waves moving around that high pressure system. So, but that high is rigid in pretty good right around that area where that cutoff is. If you look at that upper level trough, it's shooting way over that high pressure system. So that's pretty much doesn't stand much of a chance of becoming a cutoff low. If it does, it might be very short lived. Let's label this chart Frontogenesis. Alright, let's go after lapse rates. We can look at lapse rates real quick. That's not going to tell us much. I mean, we'll tell us like if we're 7 or higher, then we're looking for significant weather. Anyway, right there over the four corners is where the most of your significant weather is. Now, western Texas, we do hit the 7 right over Colorado, western Texas, and then New Mexico. So once you hit 7 or higher on the lapse rate is how much the temperature would change per 1,000 meters with height. So if you get a 7-degree change or higher every 1,000 feet going up into the upper levels, then you get a pretty good indication of instability, and that's going to give you any severe weather if you get anything outbreak right there. So with what we saw on satellite, all along this area was all that convection right along western Texas, New Mexico, and the Colorado, all along that mountain range. We had all that convection going on. So if we pull up the radar, we need to look at any isolated cells there and see what kind of upper vertical motion they got, because with these lapse rates you can have start getting those isolated supercells and get the significant weather produced out of that. So another stability chart is an advection chart here that we can use for Kelvin temperatures. These are absolute temperatures, and really nothing even showing up on this. We're looking for these pinks. If that was over land, then we could say we could have significant weather, severe thunderstorms in any of those areas. But let's go to I got another one of those that runs a little bit more aggressive, sometimes too aggressive. Sometimes I'll pull it up when I don't show anything like that. So now we got a little bit of an area right there over Louisiana into Mississippi. So getting pretty close to Arkansas where we were seeing all that instability. So we need to kind of look in this area, or these Gulf states, and see what's getting produced out of that. I'm gonna go ahead and save this chart real quick. And what else we got here? Got low level shear. This will give us an indication of rotation. Looking for wind shear. That's pretty much all where that low pressure system is, up to the northeast. I'm going to save that one. And then we'll run a mid-level shear. This one gets pretty cluttered. I don't really pay too much attention to this one. Actually, this is doing a pretty good job this time. So Colorado, western Texas, and then over the northeast. So we need to keep an eye over there too. Right on the east side of those mountains, right along the east coast. Not really what I wanted to do there. I wanted to save that chart. It's a mid-level shear. All right. So if we run a wind chill, which we don't need a wind chill chart right now, it's pretty much coming up on summer. But sometimes you can get these isolated cold pockets. So you see this 65 degrees. That's that high pressure system. That's why that thickness chart was showing us all this these lower heights all through this central United States, and it was just kind of just showing almost like just a trough, a big area of just lower heights because of that cold air in the center of this thing. So that's kind of why it explains why that thickness chart was doing what it was doing with that big blue center. But we're 65 degrees for the wind chill. It's really not a wind chill. It's just showing some temperatures based on wind, and it's one of those weather service things where it's like 68 degrees feels like 65. So basically that's your area where it feels like 65. All right, so I think that's pretty much it for the charts. We could pull precipitable water real quick and just see what kind of rainfall we should expect. Where the most of the moisture is, I suspect it's going to be in the Gulf states, as usual, with the high pressure to the south pushing to the northeast, pushing all that moisture to the north. So you can see now we're getting all the way up into the 1.8 inches into Louisiana, push it up into Arkansas, 1.7. So there's your strongest area of rainfall that we should have right into Arkansas. So we'll get an idea what's going on there too. We'll pull up the radar and we'll pull up models real quick. I'm not going to spend too much more time on this thing. It's getting pretty late. So alright, let's name that chart. Alright, let's go to model run real quick. Alright, so here's most of the moisture on the models. We're pushing up into Arkansas. We see a little bit of convection through there, and then we were over eastern Texas all through Colorado. We had that low pressure, and then high pressure over Mexico, but this is showing more of a lower pressure and then a lot of convection in that area, which we see not all on the satellite. We did see that convection, and then we seen like I said, the cirrus was spilling over the ridge all through the eastern United States, and then we do have some significant cloud cover over Arkansas. So we'll get a idea on what's going on here on the radar. First, let's run this loop. So we get the convection pushing into Tennessee, Kentucky, Indiana, Like I said, we're not going to spend a lot of time here. It looks like significant moisture all through the eastern United States, and then looks like the East Coast getting some convection, obviously through, to the Gulf states, right there through Georgia, Texas. Pretty good low pressure system popping up right out of Colorado and just pushing almost to the north and then into North Dakota. Most of the severe weather staying up in Canada. Got a pretty good isolated pocket right there in Illinois and Indiana. Then another one pops up north of South Dakota. And a little isolated cell right there in Georgia. It looks like almost like a low pressure or something popped up right there. So let's just skip through this real quick. Here's the there's the tropical storm. Like I said, that stays well to the south, pushes over to the northeast, well off the coast. We don't have to worry about that one. It looks like another significant low pressure system to the south. Now that would be one to be concerned about if this is real. These models are pretty far out, so that's a couple weeks. I wouldn't bank on that one just yet, but there is a chance of another tropical storm popping up down the southern Gulf, right off the Yucatan Peninsula, and then that could push up into the Gulf. So like I said, it has to go around that high pressure system. So pushing up into the Gulf, this one could be, that would be more accurate than, you know, the low pressure just dying off over the Atlantic. I mean, this one still has a pretty much a closed system, but I would say that thing dies off, you know, pretty far out there. I wouldn't be too concerned about that. That's actually pushing over Cuba, and then it's pushing to the north. Unless that's a separate system right there. This is that's 2 weeks out. So Blanco or whatever that one is, that one's already out there, and that one's probably going to die out well before this. So this probably is maybe a separate system. One pushing out, pushing to the north, staying off the coast, getting a low pressure system over Georgia, some wraparound onshore flow over South Carolina, a lot of convection there, and then that system down there in the southern Gulf starting to push up to the north. So in a couple weeks, few weeks, that's something to keep an eye out on these systems. So now as far as those other ones pushing through the U.S., we got, I mean, it's a 318 hour forecast. So I mean, it's, I don't know, take it with a grain of salt. A lot of your convection staying well to the north. This be Minnesota, North and South Dakota. This is 06Z Friday, June 11th. So, alright, that's it pretty much for the models. Let's go pull a radar, see what we got here. I'm down in Louisiana now. Here's a flash flood warning for Little Rock. Alright, let's get a good let's pull the radar on this and see what we got for this loop. So let me go to, okay, we got some pretty heavy rain. Doesn't look like anything severe. Obviously no severe warnings, just flash flood. Looks like it's been raining there for a little while. So let's go pull the warnings window. We have 2 severe warnings. Both are in Texas. For the counties of Andrews, Ector, Martin. Looks like maybe Midland. Let's see. And Hudspeth. Alright, so let's go over there. See what's going on. Download this loop. And we'll make this one quick. Now we do got some hail makers right here. Alright, supposed to be downloading data now. Alright, so almost 3/4 of an inch hail, just over half an inch, 0.6 inches. Both of our severe warnings. This is a 1.25 inch hail over Andrews. Alright, so for some reason I'm not downloading those images. Let's get over here to Midland Odessa. Alright, here's our cells right here. Now, pretty good. Pretty good reflectivity, so there's definitely some hail in that. Do a cross section on this thing. Pushing 50 dBZs over 10,000 feet is definitely a severe system, and we do have some high reflectivities right about 8,000 feet, so we're doing pretty good right there. Don't expect any tornadoes. Let's go do a volume scan on this. Now, it's very isolated, but does have upward vertical motion all the way up to 20,000 feet. So, I mean, that thing is a pretty significant little system right there. Now, southwest quadrant, we do have a little bit of a hook echo. No indication of rotation by radar, but it is, definitely has a little bit of a hook to it. So you got that inward flow, and then so you got that. You do have a little bit of rotation. Let's go see here. Look at the base velocity. I would say, yeah, we definitely got a little bit of rotation in that area. Alright, let's go back. Didn't want to do that. Another volume scan. Let's move this out of the way. Let's go to, I guess the other warning's gone, so we don't have to worry about that. We can do a volume scan on all these little cells, see what we got. Really nothing. Just upward reflectivities in the upper levels. Trying to drag here. Pretty much just nothing significant there. Alright, so nothing in Arkansas except for a flash flood. Do a volume scan on that real quick, and that's all at the surface. There's really nothing to be concerned about there. Just heavy rain, flash flooding, heavy rain. Definitely flash flooding is always something to be concerned about, so don't drive in any water that you can't tell the depth of it. It can be very deceiving. So alright, I'm going to end that video here. Alright, like I said, I'm going to update the website with the charts. Visit meteorology101.com. Right hand sidebar, you got surface and upper air charts. We've got a lot of articles in there. Goes pretty depth into weather. We'll go start some educational classes here someday. I keep saying that, and it's taking a lot of time to build them, so we will launch that course here someday. So like, subscribe, and share the videos. Help me build the channel, and I'll be able to spend more time on it. Thank you for watching.